Welcome back to the morning show. It's coming up on 6:50. That means it's Wednesday, Chemist Corner time. Jesse Miller joins us, teaching lab specialist from the U of I. Thanks for being here. Talking about air pressure today.
That's right. I've talked about air pressure before and how, you know, we got all this, 5 miles of air above us pushing down on us, but it's also pushing up on us, so we don't really feel that crushing weight of the air on us. But it does put out quite a bit of force, 14.7 pounds per square inch. And we're going to demonstrate that with a classic experiment. I think a lot of grade school teachers and junior high and even high school teachers have shown this, and we do it at the U of I all the time, to show how air pressure is pushing. It doesn't... A vacuum isn't a thing. A vacuum is an absence of something, which is air, okay? So you're really just looking at the difference in pressure. You got higher pressure on one side and a lower pressure on the other side. The lower pressure we call a vacuum. Okay, so we're gonna lower the pressure in this bottle, and we're gonna get this egg. I mean, I could cram this egg in here, but it would be a mess and stuff, and it wouldn't be very instructional as far as air pressure goes. But we're gonna use air pressure.
That would be force. That would be a different segment.
That'd be different, yeah, that's right. So we're gonna use air pressure to do this. And the way we're gonna do that is we're gonna try to lower the pressure inside the bottle and have the air pressure on the outside push the egg in. And I already did it on one just to make sure that we had one in there. And you know, as you can see, it doesn't fall out easily. Okay, so the way I'm going to do that is I'm going to light a little fire inside here, and the fire is going to heat up the air. The air is going to escape. A lot of the air is going to escape. And then when the egg seals the top and the fire goes out, it'll cool down, and the pressure will lower, because pressure and temperature are related, and it should suck the egg in there. And the egg may rattle on top, and that'll be some of the air escaping, and then it should get sucked in. So we'll see. Well, not sucked in. It gets pushed in. All right, so this is a little 200 proof ethanol.
A little fire starter, a little helper. Okay,
so we got our fire. Drop this in here, and then...
So that's the air.
There you go.
Bada bing.
Yeah, it goes right on in.
Very long.
That's right. Now the hard part is getting it back out. That's right. All right. So now there's two ways we can get this out. We can lower the pressure out here, or we can increase pressure in here. Now lowering the pressure outside would be a little bit difficult. We could all take a big breath, but I don't think that would work. So I need to get the air pressure inside here. Now this is my talent here, okay? I'm gonna
Your siphoning skills are gonna...
No, I'm gonna blow into the bottle, and the air pressure on the inside now will be greater, and it should push the egg out. So we'll see how this goes. All right. Now,
I'll help you out just in case.
Okay, I'm gonna catch it in my mouth. That's all right. Here we go. There we go. All right.
Awesome.
Like I said, it's 200 proof ethanol.
Yeah, so you have a hard-boiled ethanol
pickled egg. That's right, pickled egg. All right, so another kind of classic experiment, and you've seen how sometimes you get frozen food that's vacuum sealed, right? And vacuum sealed, they remove all the air out of it, and the plastic just gets sucked out, and that's actually the air pressure pushing on the plastic. It's not being pulled in. The air pressure on the outside is pushing on the plastic, and it keeps it form-fitted, so to speak. So I got my daughter here, Jessica. I didn't figure I'd be able to get Jennifer or Ann, we'll come on out here, to get into this garbage bag.
In a bag?
And I couldn't find one big enough for you. So I got Jessica here. She's going to get in this bag. And, okay, I just want to make sure we didn't have holes in the bag.
Yeah. And, again, kids, don't be playing with bags at home unless you have an adult with you and doing a science experiment.
That's right. Yeah, we're not putting it over her head, so that's probably a good thing. And we got my vacuum cleaner here. So we're going to remove all the air out of the inside of this bag, and it should... See, right now, the air pressure on the inside and the outside is equal, so the bag's just kind of floating around. But if we remove the air out of the inside, it's going to... All right. Whoa. Jessica, appreciate it.
Thank you. Now, we couldn't hear you a little bit. You said if you did what now, removed all the air, you could just seal her?
Yeah, just seal right up in there. It's kind of difficult. This vacuum cleaner, the plastic kept getting stuck in there, so we couldn't get quite all the air out of it, but, you know, it's like you end up looking like Catwoman, you know.
Right, I see that.
Like I said, we put our jeans on that way in the 70s or 80s.
All right, well, on that note, we're going to finish up this segment. We'll be back in 30 minutes with more. If you want to see a replay of this, just go to our website. There's how to get